We shall next proceed to analyze and pick out the keywords from the question of example 16a so that we can understand the question well. The man decides to invest X dollar at the beginning of each year. Okay, X dollar at the beginning of 1 year, and then a further X dollar at the beginning of the second and each subsequent year. Well, that means every year at the beginning he puts in X dollar. Then he will not withdraw any money out. So that means we don't subtract anything from the amount that he has in the bank. So how much will there be in the account at the end of 1 year? That's what the first part is asking for, including the interest. Show that at the end of n years. That's another keyword. See, the question is interested to find at the end of n years, at the end of first year. So part 2 says at the end of n years, when the interest for the last year be added, we need to show that he has a total of 21 into 1.05n minus 1 times x in his account. So what are the keywords? When we actually analyze the first part of the question, we know that there's a rate of 5% for the interest, and the interest is always given at the end of each year. Right? At the end of each year, okay, the interest is added to the account, and the amount added is 5% of the amount in the account at the beginning of that year. So we know that rate is 5%, which converts to 0.05. The man put in X dollar at the beginning of each year, and the question is always about end of each year what he has. So let us write down some expression for the first few years to understand the problem, and from there we analyze how we can apply APGP concept. So let's look at this table, which is available in your lecture notes. As I analyze, I hope you follow and jot down the numbers accordingly. Now, let's look at the very first year. The total amount at the start of the year that the man has was the amount that he puts inside the bank. That is X dollar. At the end of the first year, the interest that was accumulated was 0.05x. 0.5 multiplied to what he has at the beginning of the year. The total amount at the end of the year will be x plus 0.05x. That gives us 1.05x dollar. Now let's analyze the second year. At the beginning of the second year, he puts in a further X dollar. So the amount that he has in the bank will be 1.05x. At the end of first year, add on another X. So if we call this A, the interest that is given to him at the end of the second year will be 0.05 times A. So at the end of the second year, what he has in the bank account will be A plus 0.05A. That gives us 1.05A, and when we substitute in what we know as A, it will be 1.05 multiplied to 1.05x plus x. Now, that gives us the figure of 1.05 square x plus 1.05x. Now, do you notice the way I manage the numbers? Let's scroll up. Now, over here, when I was analyzing the amount that he has at the beginning of year 2, I could have added this to form 2.05x. But I didn't do that because sometimes in such questions when we oversimplify, it can actually make us lose the pattern. And there is a strong clue when I choose that I should not add on given by the question, because the question actually needs me to show at the end of A part 2 that I need to show an expression that has this factor of 1.05. So from there, it's quite a strong clue that I should try to retain the factor 1.05x. I had proceeded on to add on to get 2.05x, and I run into trouble later. I should come back here and relook at the way I'm managing the numbers. So do pay attention to this point, that we need to be careful with the way we simplify the numbers. Alright, let's analyze the year 3 to have even a clearer picture. So for year 3, we will need to take what we have at the end of year 2, which is this. So we will need to see what we have at the end of year 2, the 1.05 square x, add on the 1.05x, and we need to note that at the beginning of year 3 he add on another x into his bank account. That's what he adds into his bank account. So let's call this amount B. So at the end of the year 3, the interest given to him will be 0.05 multiplied to B. So the total amount that he has at the end of year 3 will be B plus 0.05B. That gives us again 1.05B. And when I sub in what he has at the beginning of the year, we will have 1.05 square x for B plus 1.05x plus x. So eventually for year 3 we will have 1.05 power 3x plus 1.05 square x plus 1.05x. Now, do you see that when we study this pattern very carefully, do you see that at the end of year 2, the power of 1.05 starts with 2, and when it's at the end of year 3, the power of 1.05 starts with 3, and the series always ends with 1.05x. Do you see, for both year 1, year 2, and year 3? So picking up such patterns actually allows me to write down the amount at the end of year n. Okay, let's get back to the table. The question here, okay, let's change this to small letter n, alright? Now, the question is asking me to work out the amount at the end of n years. Now, we observe the first 3 years, and we see the pattern that at the end of the n years, the series that I need to add, the amount that I have is always 1.05 raised to the power of n. Because for third year, I start with power 3, for second year, I start with power 2. So it's 1.05 raised to power n x plus 1.05, the next term the power subtract 1, So n minus 1x plus 1.05 n minus 2x, and so on and so forth until the last term is always 1.05x. So I see this, and let's get back to what the question say. What do I need to find? I actually need to show that at the end of n years that the interest, after the interest has been added, he has a total of how much. So which means I'm asked to find whatever I have over here, whatever the total amount at the end of year 3 that I'm highlighting now. I'm asked to find this for 16A part 2. So I observe this carefully. I see that from one term to the next, we are multiplying by 1.05, so we actually have a sum of a GP with common ratio 1.05 here. So for me to add all this up, I'm going to proceed to devise a plan to find this. So I ask myself, what formula can be helpful? So we of course have the sum of a GP given here. So, and when I've observed, I saw that the common ratio was 1.05. Next, we carry out the plan, because since I've already devised the plan to use this sum of a GP formula, we carry out the plan to execute it. Now when we are carrying out the plan, we need to be very careful of our control skills, meaning how we decide to do certain mathematical steps, such as when to factorize, when to expand, and so on, and with lots of observation in the midst of it. So let's analyze. We have already mentioned that we actually have this as whatever we have highlighted earlier on. We already have this in the table that we analyzed earlier. And how did I get this? I actually took care not to simplify too much, and I retain the terms in 1.05, right? So generally I choose to retain this 1.05 partly also because I was prompted by the question to keep that factor, and that guides me. So when we are trying to simplify, it's easier to factorize out the common terms, and so here, there we are, we factorize x and leaving a GP within the bracket. Now noting that the very first term inside the bracket has 1.05 power 1, and the last term has the power of n. The powers of 1, 2, 3 and so on right up to n counts the number of terms that we are adding, and we can see that we are adding up n terms, right? Number of terms is n. So from there, this directs us to see that when we are using this formula up here, which is the number of terms n, we are keeping this n untouched because the number of terms that we are adding is indeed n. So that's what I'm saying here in the control skill compartment. So we apply our formula, we get whatever we have here. So this is the A, this is the N, and this is the R. Now again over here, I choose to keep this particular factor intact because in the question, if you look up at the question component, you can see that the question is directing us to keep this factor untouched. So that's why in my solution, I will actually keep this factor, and I will choose to group. I'll choose to group 1.05 in the numerator with the denominator. So when I simplify this, I have 1.05 divided by 0.05 here as stated in the solution, and that gives me the 21 that requires here. Okay, now I will choose to, for the fourth step, the check and extend step, I can use the answer in part 1 to check my answer in part 2. When I substitute in the value of n equals to 1 for first year into what I've obtained for part 2, when I sub in n equals to 1, I actually get 1.05x. So which is what we obtained in part 1. Therefore my answer is correct even if it's not a proving question. Now with that, I have come to the end of 16a part 2, and in the next video we will proceed to solve part 3 and part B. Thank you.